Welcome everyone and good afternoon. We will start very shortly. Thank you. Okay, we will begin now. Henny, you can start. Good afternoon, everybody. I hope everyone can hear me. Welcome back to the Malaysian Water Association and Malaysia International Water Convention webinar series. And today is our 12th webinar. So today we have our very special guest speaker, Professor Dato Engineer Dr. A. Bakar bin Jaafar. Dr. Bakar is the chairman of Malaysian Green Technology and Climate Change Center, now called MGTC. He is also professor at UTM Perdana Center, Razak Faculty of Technology and Informatics. Dr. Bakar today will be sharing with us his presentation on conversion of excess pressure in water supply distribution networks into power and hydrogen fuel. And we invite all attendees to participate in our survey today, which we will show around during the midway through the session. And purpose of our survey is to collect feedback from everyone so that MWA can use this feedback when they make presentation to the government or regulators. So if you have questions, you can key in the questions in the icon chat at the bottom of your screen. So without further ado, I want to invite Dato Engineer Abdul Kadir bin Mohammed Din, President of the Malaysian Water Association, to deliver his welcome note before we start the session. Dato Kadir, over to you, Dato.
Okay, thank you, Dennis. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi. Ladies and gentlemen, good afternoon and welcome to today's MWA organized webinar series. And this afternoon, webinar is the 12th in the series. And today, the webinar presentation will look at an innovative topic. It's very rare topic and is upgoing in the current trend of energy. That is on the conversion of excess pressure in water supply distribution network into power and hydrogen fuel. For this, we would like to welcome, and we are lucky, I would say, to have our today's guest, Professor Dr. Abu Bakar bin Jaafar, the Chairman and Malaysia Green Technology and Climate Change Center, and he's also the Professor at the UTM Perdana Center, Razak Faculty of Technology and Information, who will present the paper to us this afternoon. It's about something that is new, that is no new hydropower. It's not dams, no reservoirs, just pipes, and I would say certainly no nuclear power plant. It's an environmental friendly projects or innovation, which suits Dato' Abu Bakar vast experience as a former head of DOE in the early days. So our esteemed speaker will share a system to generate carbon-free electricity from a previously untapped water source, the pipes under our streets. Sustainability of water supply system has started to become an important issue, besides continuous, clean and safe water supply. Sustainable water supply system require improvement of energy efficiency, reduction of energy and water losses in water distribution system, and reduction of carbon dioxide emissions. Pressure is one of the main design parameters for gravity water supply system and water distribution networks. Therefore, pressure has to be between certain limits, and excess pressure occurs during water transmission from high elevations of water resources to low elevation. Excessive pressure heads are the major problems in water distribution system. Excessive pressure may cause damage to the pipeline and leakage. Thus, excessive pressure should be minimized while customer demands are ensured to be satisfied all the time. By use of balancing reservoirs, break pressure tanks or pressure reducing valve, in short is PRV, excess pressure is reduced and damages on transmission and distribution pipes are prevented. Energy recovery from excess pressure is possible at this stage, for example, by using in-conduit turbines. Similarly, PRVs are used at certain locations of water distribution networks to control excess water pressure and to reduce it down to optimal operational levels. Since our water system moves large quantities of water through the big network of distribution pipes, why not use that flow to generate electricity? Just for an inside view, the energy cost to run a plant, or in short, to run the cost that incurred to water operator is nearly about 20 to 30% of the total cost. So it seems obvious, but in most cases, we have heard a lot about it, even though many have thought it's not practical. In any case, recent development had taken place in many pilot studies where it has proven energy recovery from excess pressure is also possible at this stage. If the water flows naturally from higher elevation, then the force that moves the water is just gravity. No man-made energy is involved, so it's possible to extract some of the energy from the flowing water and convert it to electricity. These innovative projects commonly used in a turbine to perform the function of pressure reducing valve. As the PRV hydropower turbine reduces pressure, instead of dissipating this energy like PRV, however, the turbine converts it to usable power. While the concept is simple, conduit system present special challenges and risks. Careful site assessment and planning are critical, and it is important to work with a supplier who understands the issues. Ladies and gentlemen, water agencies today face increasingly financial challenges. The high cost of energy, as I said, coupled with energy efficiency mandates and the need to repair or replace aging infrastructure, all require creative solutions to keep operations sustainable. By using their water pipelines to generate renewable energy from an otherwise untapped energy source, I'm confident the presentation today can be an important part of the solution we all seek. For water utilities which use massive amounts of electricity, the system can make it cheaper to provide clean drinking water. Utilities can either use the power themselves or sell it to TNB as a new source of revenue. Last but not least, change is finally coming to energy. Environmentally focused and governments, companies, and investors who are eyeing alternative fuel sources like hydrogen to play a role in decarbonization. Global demand for hydrogen is expected to go up, and according to the International Energy Agency, China has set a pledge for million hydrogen-powered cars, and the EU has set to deliver net zero carbon emissions by 2050. In Malaysia, it is estimated that 25 megawatt could be developed from this WSD water system distribution network at 2,500 PRVs at 10 kilowatt per PRV. 4 tons per year of hydrogen generated at 55 kilowatt hour per kilogram, and $60 of revenue annually at $15 per kilogram of hydrogen delivered, and the required capital investment for such a development recovered within less than 5 years. So it is hoped that the concept shared in this webinar today can open up our eyes and can serve as a model for research bodies and water agencies in the country to explore the value of in-pipe hydropower. MWA, on its part, is prepared to discuss with Green Technology and Climate Change Center, the universities, and the water operators to bring this subject for pilot study at a suitable location. Finally, a big thank you to the presenter, Professor Dr. Abu Bakar Jafar, for taking his time off to share with us on this interesting topic, and also to our webinar host, Protem Group, and I wish all of us successful, fruitful webinar. Thank you.
Thank you, Dr. Kadir. So now I'd like to invite Dr. Bakar, Professor Dato Engineer Dr. A. Bakar bin Jafar, to start his presentation today. Dato?
Yes, thank you, Dennis. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Salam sejahtera, good afternoon. And at the outset, I would like to take this opportunity on behalf of the Malaysian Green Technology and Climate Change Center, in short, afternoon. Also, in particular, I wish to thank Dato Kadir Din. He has invited me to appear this afternoon, and I must say at the outset, my presentation today, this afternoon, actually is an update of my presentation at last year's MIWC conference or convention last year, and I think this is an excellent opportunity for me to update what has progressed since last year, and I'm more than happy to share this new approach, how to recover the excess pressure and convert it into power. And if there are no takers of this power, then this power shouldn't be wasted, and we could easily convert this power into hydrogen. You all this afternoon. So next slide. Is anybody happy? Oh yes. Okay, the next slide, this is the outline of my presentation. Why hydrogen? Then the second is to assess how much power could be generated from our water supply and distribution networks. And third is how to convert this power into hydrogen by water electrolysis. What be the potential and prospects in Malaysia, and I finish it by conclusion, as well as set of recommendations in what way that MWA and MGTC and others could collaborate in order to realize this potential and to explore these prospects. Next slide. Okay, this is my favorite slide. Every time I make a presentation on the subject of energy, I always share this slide with one and all, and some of you could have seen this earlier. This is essentially and there are 6 primary sources of energy, and those within the solar circle, those considered as secondary sources of energy. And if you might recognize, there are 4 primary sources of energy considered renewable, and there are 2 more considered non-renewable, largely nuclear and fossil fuels. And when I say fossil fuels here, in the form of coal, petroleum, natural gas, as well as methane hydrate. These are frozen natural gas in the deep sediment at sea. Okay, this is the background on energy. So next. Okay, why hydrogen? There are a lot of studies being done, and also popular projection is that by mid of this 21st century, hydrogen is going to be the most dominant energy carrier, most dominant. Of course, natural gas, heating, cooling, and oil. But also we've been burning coal and biomass all these years. You may observe here, by 2070, there'll be no direct combustion of biomass and coal because of climate change. And that simply, the world is not going to run out of biomass, not going to run out of coal, but biomass is going to be converted to ethanol, alcohols, and coal is going to be converted to hydrogen. So hydrogen also can be sourced not only from renewables, but also can be sourced also from the non-renewables. That would be the energy carrier future for us in this century. Next. Okay, then you look at the application of hydrogen. It's not much talk about in Malaysia, the use of hydrogen for transport. And I think, and as Datuk Kadir was saying earlier, and Malaysia is about to embark on this. So far, we have bought some electric vehicles, and this some of them could be converted into hydrogen fuel vehicles. And also, we are very happy to see that Sarawak government, in particular the Sarawak Energy, has already installed a hydrogen fuel station, and they've already brought in 3 buses and 2 SUVs. And I think Sarawak, in a way, is going to make full use of excess hydropower, and this hydropower is going to be converted to hydrogen. So hydrogen is going to be a major carrier, and as you see from this figure, hydrogen fuel cell vehicle is going to be the most dominant type of vehicles compared to other types by mid this century. Next. Okay, here I would like to share with you the pricing of energy. I think we appreciate that the pricing of energy for the energy content. So in other words, if you were to buy 4 liters or 1 gallon of petrol, is equivalent if you were to buy 1 kilogram of hydrogen fuel cell. And here is where the economics come in. I think not many people are aware of this. So next slide. This is just to show to you that if you were to buy 1 kilogram hydrogen, which is equivalent to 1 gallon of petrol, you put in a hydrogen fuel cell cars, and this will take you over 100 kilometers. But for the same price, if you were to use our internal combustion engine cars, our normal cars, and we only cover 40 kilometers. So very obvious that hydrogen fuel cell cars are much more superior than our current cars. The reason very simple. I think next slide. The reason very simple. If you were to put 100% units of energy into our cars, and 71% of them wasted as heat, and then only energy, same amount that we fuel the hydrogen fuel cell cars, only 29% wasted, but 71% of the power go to the wheels. And this explains why the hydrogen fuel cell vehicles are much superior than what kind of vehicles that we have today. And of course, there'll be no pollution and only water come out. That's another plus as far as the hydrogen fuel cell vehicles are concerned. Next. Okay, this is another picture. If you want to cover this range, 250 miles, American miles, and that's about 402 kilometers. The amount of energy you require, if you were to put in the natural gas, right? And it would require 1.29 million BTUs. And then if you were to use combined cycle here, you require much less energy, 0.86. But the source of energy, the natural gas, right? So you only require 0.67, say essentially slightly less than half what you require. So this is another picture to show. Of course, the hydrogen now, most of it generated from the reformation of natural gas. But what we are after is not the hydrogen from fossil fuels, but hydrogen from renewables, including the excess pressure from our water distribution networks. Next. Okay, this I would say typical sources of hydrogen that you can generate from our hydros, dam, reservoir, river intake. And then we use PRV in order to control the pressure. As Datuk Kadir was saying, you need to control the pressure, not as much to distribute the water as. And our proposal here is to install turbines in parallel to the PRV. The PRV will still be there as a plan B, but the idea is to make full use of the existing locational sites where PRVs are installed. Okay, next. Okay, this is another view. You can see a lot of excess energy from throughout our water supply distribution networks, and I think you are the expert on this, so I won't elaborate anymore. Next. And this is a typical PRV installation, right? Then what we'll do is we just install in parallel to this installation to install our turbine and generator. Then if we need to generate hydrogen, then we install the electrolyzer at the same location. Next. Okay, this experiment must thank I must say more than 10 years. And then I suppose the uptake is very, very low, simply because the nature and also the quantity of energy generated, not consistent, intermittent. And I think that's the reason why I've been promoting since I met him, but about almost 2 years ago, that we should promote this, we must take up this excess power to convert into hydrogen. I think that'd be more, I would say, economical and also financially sound. Next. So this is another view, the experiment to show the installation of the PRV X, where we have installation of turbine to generate power and stored in the battery. But we're not going to use a battery in this our case. Next. Okay, this the power generated. There's a illustration. Next. Okay, this is the kind of turbine that you could use. This is the one, quite typical one, but the size, we may not use this size, but just to show we have already got the existing technology in order to tap the excess pressure to be converted into power. Next. Okay, this is another example. The water turbines, or sometimes they call it PAT, pumps, acting as turbines. So this is one technology that we could use. Next. This is another example of PAT, smaller next. Okay, this is another one, bigger capacity. Next. Right, this is a much bigger capacity, almost 2.6 megawatt. Right, next. Okay, similar one, configuration, next. Okay, the another is just a set of visuals to show you pump that can be used as a turbine. Next.
Dato', we'll have the short poll here.
Short questions?
Yeah.
Yes, okay, please proceed. Yeah.
So attendees, you can answer this poll here. 3 questions. Yeah, so you can scroll down to question 3. You can show the results, Henry, if everyone has finished. Oh, okay, so the result will show at the end. Fine. Okay, so now we're going to have a little message from our advertiser today. Am I correct, Henry?
Yes. Then after that, Dato' can continue after the advertiser.
Okay. Here's a little message from our
40 years ago, here at Citizen, we asked ourselves a question. What is the ideal source of power for a watch? Light is all around us, wherever we are. What if we used light to power our watches? That insight inspired us to create the world's first analog light-powered watch in 1976. That's where it all began. We called this technology EcoDrive, in acknowledgement of its eco-friendly origins. With EcoDrive, our watches generate energy from even dim light, run for months, and will never need a battery change. We've relentlessly refined the technology over 4 decades, reducing the energy needed to power our watches through countless new improvements, allowing us to capture light with increased efficiency by reshaping the solar cells. As a result, we created a whole series of watches with even more attractive dial designs. Watches with multifunctions, watches that are smaller, thinner, and more beautiful. Watches that everyone can relate to, even love. Now we've consolidated our 40 years of experience to create an extraordinary new model. The challenge, however, goes on, because we believe it's always possible to make something better. As a light power pioneer, we believe in driving the evolution of the watch and crafting timepieces that inspire people everywhere. Creating watches for all the world's citizens. That is our mission.
Thank you, everyone.
Okay, Dato', you may continue.
Okay.
You can
Okay.
open the slides.
I have another 1/3 of slide to go, so that's be be good timing. Next. Okay, I've gone through literature, and I don't think I read in the application of how to recover energy from water supply networks. I will share you the reference for this. Next. Okay, this is the characteristics of pumps as turbines, and of course, the design will much depend on the height, the height, and also the flow. Next. And this centrifugal pump operating. Next. And these are the visuals of the stool. Next. Okay, the next one is if nobody really taking up the power, and I think it's not that viable really to get this power connected to the grid. First, because the quantity of energy generated is not that big. I would say on average, I have yet to study the numbers. I think the most is can be about 300 kilowatt, maybe depends on the size of the pipe. I think on average, perhaps maybe 100 kilowatt. And I think we need to study this. But since no takers of the power, so my proposal is that we could generate hydrogen. This electrolyzer produced by a company called H2B2. And I must say, because they just won the big contract in California. And they also have achieved the US Department of Energy target, that is about 44 kilowatt hour units of power to generate 1 kilogram of hydrogen. And I think most electrolyzers in the world now, you see in the market, I think the power required is very high, it's about 50 or 55, maybe the best about 50 kilowatt hour per kilogram of hydrogen produced. So if you were to carry out the feasibility study and also to undertake the proof of concept, perhaps you can start with this, the minimum size of this electrolyzer. Okay, next. Okay, that's the some statistics. The nominal hydrogen flow that we generate from this about 2 normal cubic meter per hour. This is the smallest unit they have produced, but of course, the largest unit they have can go as high as 400 normal cubic meter per hour. Next. Okay, very unfortunate that I couldn't get exact official figures of how many PRVs installed in the country. Despite I know a lot of friends in the industry, but I think since there's no official statistics on the number of PRVs installed in the country, and even Datuk Kadir recommended me to buy this Malaysian Water Association Water Industry Guide. I bought one 2018, and there's no such table or statistics that really could tell us the number of installation of PRV. Perhaps MWA could take up this together with SPAN to release this figure so that we can work on this subject. Okay, after having talked to a number of colleagues in the industry, including I've consulted engineer Syed Mahmoud. He's been working on this subject for the last 10 years. So he thinks that maybe a good figure to work on is something like 2,500 PRVs. And if you take the minimum power that could be generated per PRV, about 10 kilowatt, is very conservative. Then we could generate 4,000 tons per year of hydrogen generated. But of course, I'm using the hydrogenics one figure, 55 kilowatt hour per kilogram on the higher side. But by right, we could use the H2B2 electrolyzer. The power required only 44 kilowatt-hour per kilogram. And if you were to assess, if you Google the market value or retail value, and from this we could see clearly that could generate potential revenue of 60 million US. So it's about almost quarter billion, right? 240 million ringgit. So that's quite a significant figure. And I've done a quick calculation based on the electrolyzers cost, based on the turbines that we install, the generator. I think could recover this capital less than 5 years. So this is very attractive for many of us who want to venture into this. But of course, it will be subject to further studies and detail that which I think Dr. Kadi mentioned now. I think we must work on this. Next. Okay, I was very fortunate while I was doing the reviews of the literature. This is the latest article released July this year, only this month. This is based on the case study of Valence. They have even used desalination reverse osmosis to use salt water to supply. So based on this case study, I would say they have claimed that per cubic meter of water they produce, they could generate a saving of 1.5 kilowatt-hour, right? And then based on our production of water in this country, this is old statistic, 2017, but we could update this. And that means we could generate 25 million kilowatt-hour per day. That's based on 1.5 kilowatt-hour saving, right? Energy saving per cubic meter. Now, I don't have the tariff, how much our water industry been paying to TMB. I just use my household statistics, or billings. So on average, I'm paying about 40 cents per kilowatt-hour. I know able to generate renewable energy to be paid about 34 cents, but I think retail maybe higher than that. So I just, for the sake of argument, I just use 40 cents per kilowatt-hour. That means the expected saving about 10 million per day, right? Then annual saving about 3 billion, 3.7 billion per year. I think this is quite a significant figure, right? And that means the 3.7 billion, right? That constitutes about 63% of total revenue. Our 2017 revenue for the whole water industry in Malaysia about almost 6 billion. So this, to me, quite significant figure. I think that will encourage us to work on this subject if this this indication is very, very promising. Next. Okay, I was saying earlier, I couldn't find the statistics or table that shows this guide could be updated with this new table, right, on PRVs. Next. So that we come to my conclusion recommendations. My first conclusion is that this excess pressure in the water distribution network, I would say, is the lowest hanging fruit for generating renewable energy. I consider this renewable energy, as Dato' Skandi was saying, because we got this excess pressure through gravity, right? When we generate the reservoir and we let it go down, so that because the gravity that also gives a bit of more energy than what we pump in. So this is the lowest hanging fruit. And if not taken up, that's what engineer Syed been saying. He's been pushing this for the last 10 years, but not taken up. But I think if no takers, then we could generate and easily convert this into hydrogen fuel. That's what I was saying. And then second, I think this subject ought to be taken up by MWA in collaboration with CASA and SPAN. and be published in its forthcoming Malaysia Water Industry Guide. I think we should make this public. Right? And Dr. Kadi also mentioned this, and I think we should approach Ministry of Environment and Water, and they should consider favorably the financing of the necessary conduct of techno-economic and feasibility studies on the conversion of the said excess power into hydrogen fuel. And of course, MGTC also looking at hydrogen. And I think hydrogen is going to be our major agenda, especially under the climate change, right? One way for us to reduce emissions is by moving towards a hydrogen economy. And MGTC, we're more than happy to collaborate closely with NWA and SPAN. I think that's the end of my presentation. I think the rest is supporting my favorite slide. I normally use this when I face the oil and gas people, right? The non-renewable energy sector. And this is said by Sheikh Yazaki Yamani, the former oil minister of Saudi. And he said this back in 1974. And he says, the Stone Age did not end for the lack of stones, and the oil age will end long before the world runs out of oil. So, and of course, there's another way of saying this. Our civilization had gone through so many ages, from Stone Age to Bronze Age to Iron and Steel Age to Industrialization Age to Digital Age. Now we come to the Knowledge Age. We move from stone to bronze, not so much the fact that we are running out of stone, but simply we find bronze better than stone. And we move from bronze to steel, copper and zinc, but we simply find iron and steel better. Then after that, we use all kind of material to move into industrialization. So so the time has come, and as we have recognized earlier, we have to continue to work on to see that hydrogen is going to be the major dominant energy carrier for us to move into the sustainable future. So I think that's the end of my presentation, and I'll be more than happy to entertain any question and answers. And I must take this opportunity to acknowledge the fact that I've been working on this subject with engineer Syed Mahmoud Syed Abu Bakar, is MD of Aquam Dam Structures, and he has been providing me the slide relating to turbines and powers generated from selected sites. So we're still working closely, and so he shares with you all the installations, and notice all his installation of hydroelectric power, but he has a smaller PRVs, or in parallel with PRVs. Okay, thank you very much, Dr. Kadir. Now the floor is yours. Yeah, back to you.
Okay, thank you so much.
Dennis, sorry, Dennis. Yeah, right.
Yeah. Henry, do you want to show the poll results now?
Yeah, good idea also.
Meanwhile, Dr. Paka, you can see at the bottom of your screen, under there's an icon Q&A. Can you see at the bottom of your screen? Yeah. So you can, so if you click on it, okay, this is the poll results, everyone.
Yeah.
So Dato, there are two questions there.
Is it question or under chat box? Is it the same?
Question Q&A.
Q&A, yeah. So I see only the chat box, yeah. I see some questions coming up from the chat box.
Yes, there is one question. Can you see?
Yeah, I've yet to find the icon for the chat box. I mean, for the question and answer. Okay. Now I can see it. Let's see. All right. The first question from the top is by KK Louis. Hydrogen is known to be the most explosive gas. Are you concerned about its mortality and production process? I think this is Heidelberg is image, right? I think everybody think hydrogen is explosive, but I think hydrogen is safer than the gas tanks that we have at our place, right? So I think this is not the problem because we know how to handle this. I think the latest technology is that when we want to handle the hydrogen, we're not to handle in terms of a compressed gas or liquid hydrogen, but we're going to solidify this hydrogen. So hydrogen will appear in a solid state, so it looks like a white powder. So that's the latest technology that we. So handling this be much more. That's the first question. The second question: why hydrogen is energy carrier? Why not directly tackle the pressure losses in the distribution method or directly feeding back to electricity? Well, hydrogen is the trouble in this country. We only, when we say energy, we associate with electricity. Electricity is just one form of energy carrier, and hydrogen is another form. I think we're not familiar with this. That's why we ask this question: why hydrogen is energy carrier? But it is an effective means of storing the power. Instead of storing the excess power in batteries, we can store it as in terms of hydrogen fuel. And this hydrogen fuel, the best way to store it without any worrying about safety is in the solid state. And then the second question, why not directly tackle the pressure losses? We're not talking about pressure losses here. We're talking about, yes, that have a lot of excess pressure, largely due to the gravity, right? And then of course, some due to overpumping, right? So what we're doing here is, instead of installing the PRVs to relieve the pressure, so we're going to take out the pressure and convert it into power and hydrogen. And then the third part of your question is directly feeding back to the electricity grid. As I've been saying earlier, one of the reasons why this subject not taken up, our mentality in this country is that any power you generate, you must connect to the grid. I think this is not quite true, you know, because TMB, they have their own constraints and not easy to get your excess energy or power to get connected to the grid. And I think TMB only take a large source of power, maybe, you know, minimum, if I'm not mistaken, 30 megawatt, you know, and the kind of power you generate, you know, from your PRV is very small, you know, but, you know, as I was saying, to the third question by Lara Tay. Good afternoon, Rato. May I know what type of PRV will be utilized? We're not utilizing PRV, right? What we are, because PRVs already been installed. We're not talking about PRV. What we're talking about, we just going to install turbine, right? So just the excess pressure be taken out by these turbines, and this additional pressure, excess pressure will be converted into power. Okay, the last sentence, not the last one. I think the next question is, how big is the hydrogen market in Malaysia? Of course, the market is very low for our purposes. I think hydrogen is already in the country and largely for industrial use, because they use a lot of hydrogen in our refining of our oil. For instance, to improve our octane in our petrol, they inject hydrogen. Vegetable oils, they use hydrogen. And these are two major, there are other applications of hydrogen. But hydrogen used as fuel, I think this is not yet, other than what now has started, it's been used in Sarawak at the moment, right, for vehicles. And there are small applications for hydrogen, you know, but in terms of market, very small. But I think our idea here is to generate new market for hydrogen in Malaysia. What would you say as a CEO of an oil and gas company? Thank you, Dato. I'm not a CEO of an oil and gas company. MGTC is Malaysian Green Technology and Climate Change Center. It is not oil and gas company. I hope I answer all those questions. Is there more there?
I think, Dato Bakar, I think
Okay, there are two more.
I think,
Uh,
yes.
Oil and gas, and okay, by Doreen Benjamin. PRVs in pipelines are already, as I was saying here, we don't remove the PRVs. Those can be used as a plan B, you know, but we're going to install turbines in parallel to the pipelines where PRVs are installed. Then this is how we tap the excess power, the excess pressure to be converted into power. And this power, as I was saying earlier, no TMB, nobody will, like to take it up because too small and intermittent. It doesn't generate not generated all the time. So there is the best opportunity for us to convert this power into hydrogen. And once we have the hydrogen, of course, this hydrogen can be used for many, many purposes. And the purpose that we are promoting now is to use this hydrogen in the new hydrogen fuel cell vehicles. And as you see, if you go to Kuching, there are 3 buses that run on hydrogen. You could be seeing a lot of hydrogen fuel cell cars in Malaysia. But you already observe in California, in Japan, in many parts of the world, they already start running or manufacturing the hydrogen fuel cell vehicles. So we're going to start this in Malaysia. Okay, any more? Okay, there's another one here. The PRV generally located in remote or build-up areas. I think PRVs is everywhere where there is a water distribution network. You can find the PRVs, especially in areas where they need to regulate the excess pressure in the throughout the pipelines. Okay, they say can be harnessed into microgrid solution to power remote sites. Unfortunately, I think we don't have much water distribution network in the remote areas, right? That's why our statistics covered by water distribution networks. So the answer is, I would say the problem is you want to introduce microgrid, then you must have a dependent power source. And as I was saying earlier, the excess pressure throughout the water distribution network is not, constant, so we cannot count on it all the time. That's the reason why we go for hydrogen option. Right, the last one more here is, hi all, I'm from Faculty of Engineering in Malaya. We have developed one in pipe hydropower system and patented. How can we collaborate? Yes, looking forward to meet up you. And please state your name or contact the organizers so that we can get hold of you. So we're looking forward to work with you. Okay, Ian Cheong, is the construction of this technology going to rely on lots of human labor? Is it labor intensive? The problem set up to harness. So this is a high skill. We don't need much laborers to do this. Engineers themselves can do the work, and site mamo himself can do the work. So we don't have, it's not labor intensive. This is considered high skill, right? High skill, kind of new, I would say, new source of employment. Many people are unemployed now, so we can also engage them. Next, this by Mr. Du. How would you reach out and collaborate with the oil and gas super major companies on this fuel? The network is lacking and no real existing facility invested and built. Not keen. Of course, we don't expect oil and gas very keen on this. So they have their own oil and gas to worry about, So I know oil and gas not keen on renewables. That's very obvious, right? So capsule form, yes, as I was saying earlier, solid state hydrogen now can be produced, in powdered form, and can come also in capsule. I think you must have seen a lot of these YouTubes where people in Japan or others, they say, hey, just put water in my car, then my car can run. Actually, it's not true, not water. Water is just a means to release the hydrogen already installed in such vehicles to release the hydrogen. So they just put water to release hydrogen from this solid state, right? So that's what you can see. Now, next by Sharifa Azuaini, is the energy saving based on production part size in not all she use for PRV, the size are also different. Yes, of course, you know, we take the opportunity. The reason why we tackle the PRVs because the water authorities, they know that such a place is without the excess pressure, they won't install PRV. So PRV is a good indication where you have excess pressure. So we just ride along with them on this. Of course, there are technologies, there are different flow, different head. They will require different kind of turbines, different kind of systems. So the engineers can figure this one out, no problem. The next one, the equipment needed to install at all locations that have excess pressure. What is the minimum pressure which can give the best ROI? Okay, this is a very detailed question. I think we don't work up at minimum pressure, right? If there's no pressure, no power is fine. But most of the time, we got high pressure. I think the high pressure, I would say, much more you can get from solar power. I know solar power, you see the sun there, but we only can capture 20% of the time. But bet the excess pressure ask, you know, how many, what is the percentage of the time they have excess pressure at a particular point. Okay, next one by Sharifa Azwaini Said Maharis. The equipment needed to install at the location that have excess pressure. What is the name? Okay, the same question. I think that's about all. There's no question from Iswadi Jawari, right? Just to thank me, I think. Okay, so that's the end of the questions. Back to you, Dennis.
Thank you so much, Dato. So thank you everyone for being with us here today. We have already showed the poll questions. We have done all the Q&A. So we would like to thank the Malaysian Water Association for hosting today's webinar, and our special thanks to Dato Bakar for preparing today's presentation and spending time with us to answer all the Q&A. So if any of our attendees would like to know more, please feel free to email us, and we'll make sure that if you have any more questions, we will forward it to Dato Bakar to answer them. And yeah, so the next slide, we just want to show our participants. This is one program that we are currently doing, the COVID-19 International Innovation Awards. So if you would like to know more, do follow our Facebook, Malaysia Technology Expo. If you have any innovations or any initiatives that you have come up with, this is probably a program that you may like to join us. Okay. Next, Henley, maybe we should announce our next event. Yep. So your slides are stuck. So our next webinar, again, is on Tuesday next week. There you are. Okay, and our topic is risk and water safety in buildings after lockdown and beyond. And we have 3 international speakers joining us next week. Mr. Gary Wyeth from Wyeth Water Consultants. He's currently based in Thailand. We have Dr. Agustin Mariscal from Kersia Group. He's based in Spain. And we have Mr. Dick Van Dyke from EnviroPure Foundation from the Netherlands. So we hope you will join us next week for this interesting topic. And don't forget, for all updates on our upcoming webinars and links to our YouTube, because all our webinars are streamed to YouTube, so you can watch them again. Yeah, so do follow us on Malaysia International Water Convention Facebook page, so you won't miss our program. Okay, so that comes to the end of today's program. I hope everybody has enjoyed our webinar today. Thank you again, Dato' Baka. Thank you, Malaysian Water Association. And we will see you again next week. So everyone, stay safe, observe your social distancing, and don't forget to put on your mask. See you next Tuesday at 3 o'clock. And bye-bye. Thank you, Dato'.
Okay, Dennis, can you, sorry, I missed the outcome of the survey. Can you share with me that one? Did you
Oh,
show
yes,
that?
Dato', we will send you. Yeah, Henry, can you show? There you are.
Okay, I missed this one. Okay.
Yes, and
good response.
we will send the report. Yes,
Yeah,
and we will send the full
very,
report to you, Dato'.
more than 2/3, which is very good. Yeah, right. Right. Okay, thank you very much. Thank you,
Thank you,
Dato'.
Dato'.
Yeah, thank you, Dennis. Yep.
Thank you, Dato'. Thank you.
Thank you, Dato'.
Thank you, everyone. Thank you, Dato' Kadir, Mr.
Yeah,
Lee,
sure.
who's in the background. Thank you.
And Dennis, to share
participant.
the number of this gentleman from University of Malaya is Wadi Jauhari.
Yes. Henny, you have his contact, right?
I don't have his contact, but you can.
He should be in the registration.
Yes, we have his.
You can share. Yeah, I think he's the only one.
Yes.
Express interest to collaborate. Yeah, I think
Yes.
from University of Malaya.
Yes, Jauhari.
It's Wadi Jauhari. Yeah. Right.
Yes. So we will share his contact with you, Dato', and we'll get all reports over to you. Anyone who wants to have the presentation slides can let us know.
Yeah. Okay, thank you very much.
Thank you, Dato'.
Thanks. Thank you, Sheila. Thank you, Gary, Tessiera, Shakina, Kaiding. Thank you, everyone. Have a good afternoon.